For hundreds of years, lead has been mined, smelted, refined, and used in products in the United States. But lead can be harmful to humans when ingested or inhaled, particularly in children. Lead risk assessment is unique when compared to other environmental contaminants.
There's a lot of information known about the health effects of lead on children, and some of those effects, such as neurobehavioral development and IQ, occur at such low blood levels that they're basically undetectable. They don't have a threshold. EPA uses a biomarker, blood lead concentrations, to assess risks to children from exposures to lead.
To assess risk and support remedial goals at Superfund sites, the EPA developed the Integrated Exposure Uptake Biokinetic Model for Lead in Children, or IEUBK model. The IEUBK model is a standalone PC-based software package that estimates blood lead concentration in children under the age of 7 exposed to lead-contaminated media, including water, air, diet, and dirt. Results from the IEUBK model are then used to associate environmental exposures with risk and help inform cleanup decisions and preliminary remediation goals, or PRGs, for soil at lead-contaminated sites. The IEUBK model addresses 4 components of environmental risk assessments. They are exposure, uptake, biokinetics, and variability. The IEUBK is a biokinetic model. Biokinetic models assess routes of environmental exposure to a substance and determine the distribution of the substance in body tissues. Biokinetic models are most useful for lead risk assessment when there is a known effect associated with specific tissue concentrations in humans. For instance, from research, we know reduced IQ is possible in children at a blood lead concentration of 10 micrograms per deciliter. In 2012, the U.S. Centers for Disease Control and Prevention adopted the 97.5th percentile of the distribution of blood lead concentrations in children as a reference value to identify children with elevated blood lead levels for case management.
The model is based on empirical data and scientific studies of the distribution and behavior of lead in the environment to produce a plausible distribution or a geometric mean of blood lead concentrations in a hypothetical child or the population of children.
The relative variability of blood lead concentrations around the geometric mean is defined as the geometric standard deviation, or GSD. The GSD allows for the calculation of plausible distribution of blood lead concentrations in a population from model results. From this distribution, the IEUBK model estimates the probability that a child's or a population of children's blood lead concentration will exceed a level of concern. The 4 components of the IEUBK model mathematically and statistically link environmental lead exposure to blood lead concentrations for a hypothetical child or population of similarly exposed children. The exposure component includes the types of media where lead may be present, including air, diet, water, soil, dust, and other. Uptake is the movement of lead into the body through the lungs and gastrointestinal tract. Biokinetic is the movement of lead between body tissues and excretion of lead from the body. And variability is the blood lead distribution associated with interindividual and biological variability. The model accepts exposure data on an annual basis and allows for entry of site-specific information to characterize a cumulative average exposure for each environmental medium. Like all model applications, it's important that users of the IEUBK model understand its strengths and limitations, the process by which the numerical accuracy of model predictions has been verified, and the extent to which model predictions are supported by comparisons with real-world data. The process of model evaluation addresses this range of considerations, all of which affect user confidence. In broad terms, an evaluation of the IEUBK model validity therefore includes the following considerations. The scientific foundations of the model structure. Does the model adequately represent the biological and physical mechanisms of the modeled system? Are these mechanisms understood sufficiently to support modeling? Adequacy of parameter estimates. How extensive and robust are the data used to estimate model parameters? Does the parameter estimation process require additional assumptions and approximations? Verification. Are the mathematical relationships posited by the model correctly translated into computer code? Are model inputs free from numerical errors? Empirical comparisons. What are the opportunities for comparison between model predictions and data, particularly during conditions under which the model will be applied in assessments? And are the IEUBK model predictions in reasonable agreement with relevant experimental and observational data? The IEUBK model is considered valid and accurate.
The model was internally and externally validated. It was also reviewed by EPA's Scientific Advisory Board and the National Academy of Sciences and determined to be a useful tool for Superfund risk assessment.
The IEUBK model does have some limitations.
One key limitation of the model is it shouldn't be used to predict blood lead levels above 30 micrograms per deciliter. This is well above the typical range found at EPA Superfund remedial sites, so that's really not a problem. Another important limitation of the model is that it shouldn't be used for exposure periods of less than 3 months or where exposure occurs less than 1 day in a week.
Finally, it is not the goal of the IEUBK model to match the measured blood lead of a specific child. The model is designed to predict the distribution of blood lead concentrations for an entire population for a given exposure, or the probability that a child with a specific exposure scenario would have an elevated blood lead concentration. The observed blood lead level for any child should fall within the blood lead distribution predicted by the IEUBK model when the exposures to that child are used as model inputs. For more information, please visit the website listed on screen.